ሰላም ጤና ይስጥልኝ የዚህ የኤስኤምቲ ቲዩተር ቲዩብ ተከታታዮች እንዴት ናችሁ? ዛሬ ኢንትሮዳክሽን ቱ CFD and practical approach የሚል ቪዲዮ ይዤላችሁ መጥቻለሁ። ይህ ቪዲዮ ተከታታይነት ያለው መሰረታዊ የCFD ወይም የኮምፒቲሽናል ፍሉይድ ዳይናሚክስ ዕውቀት የሚያስጨብጥ ኮርስ ነው። ኮርሱ የሚሰጠው ከሶፍትዌር ጋር ነው። ከቤዚክ እስከ አድቫንስ ድረስ የሚደርስ ነው። ስፔሻሊ የሜካኒካል ኢንጂነሪንግ ተማሪዎች፣ አውቶሞቲቭ ኢንጂነሪንግ ተማሪዎች፣ ኤሮስፔስ ኢንጂነሪንግ ተማሪዎች፣ ኤሮናቲካል ኢንጂነሪንግ ተማሪዎች እና ለፋይናል ይር ግራጁዌሽን ፕሮጀክታቸው እጅግ በጣም ጠቃሚ የሆነ ሶፍትዌር ነው። ኮርሱ ከሶፍትዌር ጋር ነው የሚሰጠው። ሶፍትዌሩ ANSYS Workbench ነው የምንጠቀመው እና አሁን ወደ ኮርሱ እንገባለን። Introduction. What is Computational Fluid Dynamics or CFD? CFD is the analysis of the system involving fluid flow, heat transfer, and associated phenomena such as chemical reaction by means of computer-based simulation. ከፍሉይድ ፍሎ ከሂት ትራንስፈር እንዲሁም ሌሎች ተያያዥ ፌኖሜና like chemical reaction or it may be combustion, it can be solving by using computer-based simulation. ያ ማለት ምንድነው? በኮምፒውተር በመጠቀም ሶልቭ የምናደርግበት ሜተድ ነው ማለት ነው። CFD has also become one of the three basic methods or approach that can be employed to solve problem in fluid dynamics and heat transfer. The technique is very powerful and spans wide range of industry and industrial application area. በኢንዱስትሪ ይሁን ከኢንዱስትሪያል አፕሊኬሽን ኤሪያ ውጪ በብዙ ቦታ ላይ ልንጠቀመው የምንችል ቱል ነው ማለት ነው። CFDs enable scientists and engineers to perform numerical experiment, computer simulation in virtual flow laboratory ኮምፒውተራችን ላይ በመፍጠር እንዲሁም CFDን በመጠቀም numerical ኤክስፐሪመንቶችን መስራት የምንችልበት መንገድ ነው ማለት ነው። Application of CFD as educational tool, advanced education course, UG introductory course በመስጠት ተመራቂዎች በገበያ ላይ ተፈላጊ እንዲሆኑ ያስችላል። ሁለተኛው ዲዛይን ቱል ዲዛይን ማድረጊያ መሳሪያ ሊሆን ይችላል። ይህም analysis and design environment in industry and also we may use it as design optimization tool. ሶስተኛው as research tool እንዲሁም ምርምር ለማድረግ ልንጠቀምበት እንችላለን። Creating virtual wind tunnel on your computer you can create virtual wind tunnel for experiment and additionally we may use numerical experiment for research investigation. Computational fluid dynamics የሚይዛቸው የኮርስ አይነቶች in order to solve numerical equation, computer scientists using the high level computer programming language convert equation into computer program. three ዲሲፕሊኖች አሉ አብረው CFD የሚለውን ኮርስ ወይም CFD የሚለውን ኮንሰፕት ለማምጣት ሶስት ኮርሶች አንድ ላይ መርጅ ሆነው ነው። አንደኛው ፍሉይድ ዳይናሚክስ ነው፣ ኢንጂነሪንግ ፍሉይድ ዳይናሚክስ የምንለው ነው። ሁለተኛው ደግሞ ማቴማቲክስ ነው። ሶስተኛው ኮምፒውተር ሳይንስ ነው። እነዚህ ሶስቱ ፊልድ ኦፍ ስተዲ ኮምባይን ሆነው ኮምፒቲሽናል ፍሉይድ ዳይናሚክስ የሚለውን ኮንሰፕት ይሰጡናል ማለት ነው። ፍሉይድ ፍሎ ኢንካውንተር ኢን ኤቭሪዴይ ላይፍ ኢንክሉዲንግ የዴሊ ላይፋችን ከፍሉይድ ፍሎ ጋር የተቆራኘ ነው። እነዛም ሜትሮሎጂካል ፌኖሜና ሬን፣ ዊንድ፣ ሄሪኬን፣ flood, fire, environmental hazard, air pollution, transport of contaminants, heating, ventilation and air conditioning of building, car, combustion in automobile engines and other propulsion system, interaction of various objects with surrounding air or water, complex flows in furnace, heat exchanger, chemical reaction, process in human body, blood flow, breathing, drinking and so on and so forth. ምናልባትም ሜትሮሎጂካል ፌኖሜና ሊሆን ይችላል። ዝናብ፣ ንፋስ፣ ጎርፍ፣ እሳት። ሌላው ኤንቫይሮንመንታል ሃዛርድ ሊሆን ይችላል። ኤር ፖሉሽን፣ ትራንስፖርት ኦፍ ኮንታሚኔትስ የአየር ብክለት ጋር በተያያዘ ሂቲንግ፣ ቬንቲሌሽን ኤንድ ኤር ኮንዲሽኒንግ ኦፍ ቢልዲንግ ዴሊ ላይፍ ጋር የተቆራኙ ናቸው ማለት ነው። እነዛ ከፍሉይድ ፍሎ ኦር ፍሉይድ ዳይናሚክስ ጋር ሪሌትድ ስለሚሆን ነው። Why use CFD? Numerical simulation of fluid flow will enable numerical simulation የምንለው ወይም ደግሞ በCFD ሶፍትዌር ሶልቭ ልናደርግ የምንችለው architect to design comfortable and safe living environment, design of vehicle to improve the aerodynamics characteristics, chemical engineer to maximize the yield for their equipment, petroleum engineer diverse optimal oil recovery strategy, surgeon to cure artillery disease, computational hemodynamics, methodologist to forecast the weather and warn of the natural disaster, safety expert to reduce health risk from radiation and other hazard, military organization to develop weapon and estimate the damage. ስለዚህ ሴፍቲ የምንጠቀምበት ምክንያት ኮምፎርታብል የሆነ የተመቸ ላይፍ ሴፍ የሆነ ኢንቫይሮንመንትን ለመፍጠር to design high performance ተሽከርካሪዎችን ለማምረት ፔትሮሊየም የሚፈልጉ ኢንጂነሮች በቀላሉ ፔትሮሊየም የማግኘት ስትራቴጂያቸውን እንዲቀይሱ ዌዘር ኮንዲሽን ፎርካስት ለማድረግ ራዲዬሽን እና ሌላ ሃዛርድ የሆኑ ለህይወታችን ለጤናችን ጠቃሚ ያልሆኑ ነገሮችን ወዲያው ዲቴክት ለማድረግ እንደሚውል ነው። application of safe example aerospace safety is well known application to aerodynamics by calculation of the lift force on an aircraft wingspan and beyond. Automotive engineering safety has many advantages. It is used to optimize existing engineering components and system to improve energy efficiency and improve in-car environment. Sport very recently one of the most innovative use of safety in the sport arena is to design the optimum stroke to achieve propulsive efficiency. ይህ ከላይ የጠቀስኳቸው በኤሮስፔስ ኢንዱስትሪ ውስጥ በአውቶሞቲቭ ኢንጂነሪንግ ውስጥ በስፖርት ኢንዱስትሪ ውስጥ እና በሌሎችም ጭምር የሴፍቲ አፕሊኬሽን አገልግሎት ላይ እንደሚውል ነው። Experiment versus simulation. Historically in 1960 to solve a problem related to fluid dynamics there was two approach world of theory and experiment. Nowadays due to the advent of high speed digital computer combined with development of accurate numerical algorithm for solving problem on this computer has revolutionized the way we are studying and practicing fluid dynamics today. This known as the new third approach world or safety. ቀደም ባለው ጊዜ በ1960 ፍሉድ ዳይናሚክስ ጋር ሪሌትድ የሆነ ፕሮብሌሙን ሶልቭ ለማድረግ ሁለት አፕሮች ነበረ ቲዮሪ ኤንድ ኤክስፐሪመንት ነው። በዚህ ጊዜ ደግሞ ሃይ ስፒድ ኮምፒውተር እና the development of accurate numerical algorithm በመኖሩ ምክንያት አዲስ ሪቮሉሽናይዝድ የሆነ አፕሮች መጥቷል። ያ አፕሮች ምንድነው? the new third approach world ይባላል ወይም ደግሞ CFD experiments። በኤክስፐሪመንት ልናገኝ የምንችለው quantitative description of flow using measurement for one quantity at limited number of point limited በሆነ for laboratory scale model ብቻ የተሰራ for limited range of problemum limited የሆነ ማለት ነው። when we go to simulation quantitative prediction of flow phenomena using CFD we can predict a fluid flow phenomena by using a CFD that will be a numerical simulation for all design quantity high resolution in space and time for actual flow domain for virtual any problem and operating conditions for actual flow domain simulate ማድረግ እንችላለን any problem and realistic operating condition. As rule, CFD does not replace the measurement completely by the amount of experimentation and the overall cost can be significantly reduced. CFD የመጣው ኤክስፐሪመንትን ሪፕሌስ ለማድረግ ሳይሆን አብሮ ከCFD ጋር ለመሄድ ነው ማለት ነው። Experiment it is expensive, it is slow, sequential, single purpose. When we are using simulation, it can be cheap, fast, parallel, and also it can be used for a multi-purpose. Equipment and personnel are difficult to transport. CFD software is portable, easy to use and modify. Let's proceed to CFD simulation. CFD simulation, the result of CFD simulation are never 100% reliable. CFD የምናገኘው ሪዛልት ሙሉ ለሙሉ 100% reliable ነው ማለት ሊያስቸግረን የሚችል ሁኔታ ሊኖር ይችላል። ኬዝ የሚያደርገው the first it will be probable case for not having the 100% reliability on CFD simulation. The input data may involve too much guessing or imprecision. Second cause, it may the mathematical model of the problem at hand it may be inadequate. The third, the accuracy of the result is limited by the available computing power. It is based on your computing power or computer. It will be limited the result. The accuracy of the result it may limited by the availability of computing power. There are many advantages of computational fluid dynamics. The first advantage, the theoretical development of computational science focus on the construction and solution of the governing equation and study of various approximation to this equation. It is one of the advantages that used to study the theoretical development of computational science for focusing on the construction and solution of governing equation and studying of various approximation to this equation. That will be the first advantage. The second advantage, CFD complement experimental and analytical approach by providing an alternative cost-effective means of simulating the real fluid flow. The third advantage we got from CFD. CFD can simulate flow conditions that are not reproducible in experimental tests found in geographical and biological fluid dynamics, such as nuclear accident scenario or scenario that are too huge or too remote to be simulated experimentally. በCFD real condition መፍጠር እንችላለን። ለምሳሌ ከጂኦግራፊ እና ባዮሎጂካል ፍሉይድ ዳይናሚክስ ጋር ሪሌትድ የሆነ ኒውክሊየር አክሲደንት ሴናሪዮ ጋር የተያያዘ እንዲሁም ደግሞ ሂውጅ የሆነና ሪሞት የሆነ ኤክስፐሪመንትን በኮምፒውተር ላይ ቢልድ በማድረግ ኤክስፐሪመንት መስራት እንችላለን። that will be the third advantage. CFD solution procedure. A beginning. How does a CFD code work? How does a CFD code work? CFD codes are structured around the numerical algorithm that can be tackle fluid flow problem. CFD algorithm structure የተደረገው በአልጎሪዝም ነው፣ በኑሜሪካል አልጎሪዝም የፍሉድ ፍሎ ፕሮብሌምን ለመፍታት በሚያስችል መልኩ CFD or Computational Fluid Dynamics software built የተደረገው በዚህ ኮድ ነው። ኮድ contain three main elements. The first it will be pre-processing, second solver, the third post processing. CFD ኮድ የተገነባው ወይም ኑሜሪካል ሲሙሌሽን ለመስራት የተገነቡ ሶፍትዌሮች ቤዝድ የሚያደርጉት እነዚህን ሶስት ኮዶች ነው። የመጀመሪያው ፕሪ ፕሮሰሰር እንለዋለን፣ የሁለተኛው ሶልቨር፣ the third post processor. ፕሪ ፕሮሰሰር የመጀመሪያው ፕሪ ፕሮሰሰር፣ ሁለተኛው ሶልቨር፣ የሶስተኛው ደግሞ ፖስት ፕሮሰሰር እንለዋለን ማለት ነው። what is pre processor? ፕሪ ፕሮሰሰር ምንለው ምንን ነው? ፕሪ ፕሮሰሰር መጀመሪያ የምናገኘው one of the code that can build computational fluid dynamics softwares, definition of geometry of the region of interest, the computational domain, and second that include definition of fluid property. The other component which is found in the pre-processing processor, the selection of the physics and chemical phenomena that need to be modeled. Additional, the other component which is found in the pre-processor stage, grid generation, that's the subdivision of the domain into a number of smaller non-overlapping subdomain, a grid for mesh of cell or contour volume element. Grid generation, the subdivision of the domain into a number of smaller non-overlapping subdomain, a grid or mesh of cell for control volume or element. በፕሪ ፕሮሰሰር ውስጥ ፕሪ ፕሮሰሰር ስቴጅ ላይ የምናገኛቸው ኮምፖነንቶች አንደኛው definition of geometry of the region, ጂኦሜትሪው ሞዴል ማድረግ እና computational domain ወይም ደግሞ ፍሉዱ ፍሎ ያደርግበታል የምንለውን region ማወቅ። definition of fluid property should be defined. The density, the viscosity, all the fluid property should be defined in this stage. ሶስተኛው physical and chemical phenomena select ማድረግ ነው። አራተኛው grid ጀነሬት ማድረግ ነው። ኮምፒውቴሽናል ዶሜን የተሰራበትን ቦታ ግሪድ ጀነሬት ማድረግ አንደር ፕሪ ፕሮሰሰር ስቴፕ ላይ የምናገኘው ነው ማለት ነው። ስፔሲፋይንግ ኦፍ አፕሮፕሪየት ባውንደሪ ኮንዲሽን አት ኢች ሴል which coincide with or launch the domain boundary. Second stage or second code element is solver. Using out of three distinct stream of numerical solution technique, it may be finite difference, finite volume method. Performing approximation of the unknown flow variable by means of simple function. Discretization by substitution of the approximation into governing flow equation and subsequent numerical manipulation. Solution of the algorithm equation. በሶልቨር ውስጥ የምናገኘው መጀመሪያ የትኛውን ኑሜሪካል ሶሉሽን ቴክኒክ እንደሚጠቀም ማወቁ ተገቢ ነው። አፕላይ ለማድረግ ፋይናይት ዲፈረንስ ሜተድ አለ፣ ፋይናይት ኤሌመንት ሜተድ አለ፣ ፋይናይት ቮሊዩም ሜተድ አለ። ሰከንድ የማይታወቀውን ቫሪያብል በአፕሮክሲሜሽን በሲምፕል ቫሪያብል ሪፕሬዘንት ማድረግ ነው። The third code element of CFD, it is post processor, many of which have outstanding graphic capability. The leading CFD package now are equipped with versatile data visualization tool, many of which have outstanding graphic capability. That leading CFD package are now equipped with versatile data visualization tool. XY plots are mainly two-dimensional graph, most precise and quantitative way to present the numerical data. A vector plot provide the means a vector quantity is displaying at discrete point by an arrow. Contour plot is another useful and effective graphics technique that is frequently utilized in CFD result rainbow scale color map, animation and streamline. Post processor, many of And lastly, the result it may display by using animation and streamline. In the post-processor stage, የምናገኘው process ያደረግነውን result in the form of graphic capability, in the form of XY plot, in the form of vector plot, it may be in the form of contour plot or animation, streamline, etc.